Welcome to Module 3. I personally love geometry, so leaving the rigid transformations is fine. We are still going to talk about a transformation today, but we are going to talk about a different kind of translation. What lies behind the same shape? So if you read this, it says two geometric figures are to be similar if they have the same shape but not necessarily the same size. So similarity means same shape but different size. There is a transformation that talks about same shape but different size. So a dilation is what has a same shape but different size. Dilation, similar figures. And similar, once again, means same shape but not necessarily the same size. So similar figures that are adjusted by a scale factor. And scale factor we abbreviate as SF. We talked last year about scale factors in 7th grade. We talked about dilations. Dilations, again, similar figures. So the shape is going to stay the same, but it's going to change size. And we have two different types of dilations. And I'm going to try to make it easy. Gets big. If something gets bigger, it is called an enlargement. And if it gets smaller, it is called a reduction because we're reducing the size. So similar figures are usually based off of a scale factor. Scale factor is something that we're going to multiply by. So if the scale factor is 4, 4 is greater than 1, therefore our figure will get bigger. If we, let's say, multiply by 1/2, it's smaller than 1, it will shrink. So an enlargement, reduction. Okay, so dilation is a similar figure that's adjusted by a scale factor. Mr. H, you haven't even started the lesson. You're right, but you need to know this. Okay, so coming over here, my laptop's all wonky now. What's going on? There we go. So we are trying to say, is pair A similar figure? Well, do these look the same? Sure they do. This one's small, this one's big. These are absolutely similar figures. And if this was the original and this was the second, I would call it an enlargement. Is that what it asks us to do? No. But they're similar figures because they have the same shape but different sizes. What about letter B? So letter B has a square and a rectangle. So is a square the same shape as a rectangle? So this isn't the same as this. If I drew a bigger rectangle, B and this would be similar figures, but a square and a rectangle are not similar. Okay, a square and a rectangle are not similar, so that won't work for me. Okay? So moving on. We've got pair C. What's pair C talking to us about? We've got, let's see, I think it's a pentagon. 1, 2, 3, 4, 5. So we got two pentagons. They're exactly the same size. Is that all right? Sure. Those are still similar figures because they're the same size or same shape, and in this case, and same size. Is that fine? Absolutely. Absolutely. And here's my favorite, circles. These are similar. Any two circles will always be similar figures. Any two circles will always be similar. It does not matter how much bigger or smaller. A circle is a circle is a circle is a circle. They will be similar. So similar figures, same shape, not necessarily the same size, but it can be the same size. So let's keep trying. What else we got here? Okay. So this one's turned a little bit. Does that matter? No, because again, we don't care about the turn. All we care about, same size, or I'm sorry, same shape, seems to be different sizes. Sure. So these are similar. What about these guys? Smaller, bigger? Yeah, it's like increasing the font size. So those are similar. And that's a good way to think about it. If you increase the font size on the computer or in your phone or whatever, do they still look the same? If I increase the font size or decrease the font size, does my face get flat like that? So they appear to have kind of the same face, but they're not the same shape. So this is not similar. What about this? So this is a really tight arc. This is a really big arc. If I was going to make this similar, I would draw something like this. It would just be taller. It wouldn't be wider. So this is not similar either. Similarity. Same shape, maybe different size. Okay? So same shape, but probably different size. Questions on any of these? I mean, it's a computer. You can't really ask a question. You can try. Like if you start talking to your computer and say, Mr. H, I've got a question. Your parents might look at you funny. Whichever class you're in watching this might look at you funny. Okay. So now we have stuff where we're talking about our scale factor. There's a couple different things that we need to understand. We've got what's called a pre-image and an image, and that's important to know immediately. When it does not have our tick marks, our primes, when it does not have the primes, this is called the pre-image. Hi, Ella. Hi. This is called the pre-image. What is the length of the segment OP prime? This is called the image. So we've always got a pre-image and an image. If segment OP is dilated, that means there's either an enlargement or a reduction by a scale factor of 4. What is the length of the segment? Okay, so we've got OP prime equals 4 times OP. Why? Because we're taking our pre-image and we're multiplying it by that scale factor. So now I've got OP prime equals 4 times 5. You should have been able to look at the scale factor and say, hey, this dilation is absolutely going to be an enlargement because my scale factor is larger than 1. So now I've got OP prime equals 20. And if you put that, I would mark it wrong. Miss Blair, I'm assuming, would mark it wrong. We're talking about inches. So it's 20 inches because the scale factor is bigger than 1, which means it is an enlargement. Just looking at this, just looking right here, it's dilated by a scale factor of 1/2. So is it going to be bigger or smaller than its pre-image? Well, you should be saying something. I mean, you're looking at your computer probably like this guy's dumb, which is probably also true. But we've got OP prime equals 1/2, which is my scale factor, times 5. It's going to be a reduction. My scale factor is smaller than 1, therefore it's a reduction. I prefer fractions, but because we're talking about inches, 1/2 times 5 is 2.5 inches. If you wanted to put 5/2 inches, you could. Or if you wanted to put 2 1/2 inches, you could. I prefer mixed numbers, but when we're talking about like, inches, decimals are fine as well. So this is how we are finding our image. So when we're given a scale factor, it's the image equals scale factor times pre-image. And this is going to be an important formula for you to know. It's the image equals the scale factor times the pre-image. Let's see, is there anything else I want to go over? Heck yeah, I do. Last one. Last one. Try not to make the video too long. Use the diagram below to answer questions 2 through 6. Let there be a dilation from center 0. Immediately, here's P, here's Q. That image is getting bigger. So I know my scale factor is going to be bigger than 1. So let there be a dilation in the diagram below, blah, 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 blah. If the scale factor is r equals 3, what is the length of OP? Well, we don't know what OP prime is. We take 3, which is my scale factor, times 3, which is my preimage, which means from here to here is 9 inches. Not from P to P prime, the entire segment is 9 inches. Or not 9 inches, Mr. H, helps if you read, 9 centimeters, which means between P and P prime is 6 centimeters. Could I do the same thing with this one? Sure, if the scale factor is 4, but let's see what other questions we have because maybe I'm jumping ahead. Use the definition of dilation. I would use this right here. Scale factor is 3, okay, so still staying as 3. So now I'm trying to figure out all of this. So once again, OQ prime is 3 multiplied by my preimage. So OQ prime is 12 centimeters. So the whole thing is 12 centimeters. But if it asks for just Q to Q prime, then it would be 8 centimeters. Because this portion plus this portion is what gives me the whole thing. There's more questions. Where was I? Aha. If you know that OP is 3 and OP prime, and this is an important question. This is probably the most important question that we have because now it's asking us to do it in reverse. OP is 3, OP prime is 9. How could you use this information to determine the scale factor? So first off, we have image equals scale factor times preimage. Our preimage is the one that does not have the delta or the tick marks. So now I have 3. My image is 9. They called the scale factor R. So I have R times 3 equals 9. How can I isolate R? Well, to get R by itself, it's R times 3. We divide both sides by 3. 3 divided by 3 is my inverse. That leaves me 3 on this side. R is 3, so I would say my scale factor is 3. Does that make sense? Absolutely, because my preimage is smaller than my image. So it got bigger, therefore it is an enlargement. This is Module 3, Lesson 1, talking about scale factor, similarity, and dilations. Here's all your lesson summary, but listen, I am your lesson summary. You're welcome.